Okay, so I'm going to be working on this problem from grokking the coding interview called employee free time. Here is the corresponding problem on LeetCode. It is a hard problem, so there's no guarantee that I'll be able to solve it, but I'm still going to give it a shot. Um, and for this problem, the description states we are given a list of schedules of employees, which represents the working time for each employee. Each employee has a list of non-overlapping intervals, and these intervals are in sorted order. Each employee is so I see. Okay, so there are multiple lists here with multiple intervals. Okay, that makes sense. Okay, return the list of finite intervals representing common positive length free time for all employees, also in sorted order. Even though we're representing intervals in the form xy, the objects inside are intervals, not lists or arrays. For example, and they list a few examples here that are not defined. Also, we wouldn't include intervals like 5, 5 in our answers since they have 0 length. So right away, there are a few things I noticed about this problem, and things I would consider doing. I can't think of a solution right off the top of my head that would result in a O of n times solution. I'm thinking of gathering all the schedules and sorting them by start time, which is pretty common for interval problems. I'm also thinking of is I'm thinking of iterating through each of the intervals and keeping track of the end time. If the end time of the first one if the end time of this current interval is less than the start of the next interval, and not equal to, just strictly less than the start of the next interval, then I think that's a time where all the employees have that time free. Yeah, we can see this example. We'd go 1, 2. 2 would be greater than 1, so this does not count. We see this 1, 3. 3 is less than 4, so we create a new interval, 3, 4 here. And then we go from this interval 5 to 6. No, from 4 to 10. And then to 5 to 6. If we go to 4 to 10, we see 10 is greater than 5 to 6. But I don't think we should be strictly removing the interval with the going in sorted order, because there is for example, we have the interval 410 like we see here in in the problem statement, we have the interval also of 5, 6. So 4, 10 here. Oh, this is a bit large. Interval from 4 to 10. That looks like something like 4 to 10. We also have the interval, I think it was 5 to 6. Was it? 5 to 6, yeah. So that would look something like 5 to 6 here. And then we have this interval. Let's say we had another one from 7 to 8, which would be like right here, 7 to 8. Normally, if our algorithm normally if we were to go about our algorithm in the way that I previously thought about, where we're iteratively going through each of the arrays in sorted order and discarding the we're just iteratively going through the array. This wouldn't work because we'd reach 4 to 10. We'd check is 10 less than 5. That would be no. So then we move on to 5 to 6. Is 6 less than 7? That would be yes, and that would incorrectly give us a free interval from 6 to 7. If we had stuck with this larger interval, then that would be fine. I think we should keep track of largest and time so far. Yeah, so we're keeping track of the largest n time so far. So we'd keep track of this 10, and then when we do the comparison, we don't compare 6 to 7, we compare 10 to 7, and we see that 10 is greater than 7, so we do not have this free interval from here to here. Okay. So I think we can break this down into multiple parts. I want to create a list of all the intervals. And I need to be clear about how to do this. So schedule is a list. Okay, sorry for the brief delay. I had to talk to my mom. Okay, so we're creating a schedule. For let's just go intervals. I'm gonna just create this. This is not necessary, and I think it might cause additional space complexity. But I think yeah, I think this would be easier to work with. Okay, so for interval in schedule start val is equal to enter start, enter dot end, intervals dot append val, and then we'll just sort based off the this might be better to. Now this is kind of hard to sort individually because we do this, we have time complexity of n times m times whatever else log n times m times. Whereas if we did all of it before, it would just be additive, and then we'd iterate through it once. But we still need to do log k. Yeah, no, this is slightly less efficient, but it's fine. No, is that true? It's not multiplied, it's still additive. Okay, so this would be like n plus m plus log n plus m plus whatever. This would be our runtime complexity for this intervals, and this is each schedule of the employee. Okay. Intervals at sort for k. If intervals, if not intervals, I think we could just straight up return interval with no start or end. That's the expected return type. Is it a list of intervals? I believe so. I don't like this formatting. I understand why they're doing it, but I'm just making sure that this works. So this is a list for enter in list. Yeah, that's what I figured. Okay. I feel like I'm embarrassing myself. Okay, so this is a list of intervals, so we're iterating through each list. And then for each interval in each list, we append it to our intervals list. So what's the problem? Runtime error. Type none-type is not iterable. Not schedule return I'm gonna continue with the code, and I'll continue to debug later, but I'll keep this in the back of my head. So we're just gonna assume that each interval is start, end. Okay. And then res, we have a list. So prev end is equal to intervals dot 0, 1. This is the first end of our intervals. Do we really care about the starting time of the first one? I don't think we do. Okay, so for I in range length of intervals, this is just skipping over the first interval. Okay. And equals intervals I if the end of the interval, if the start of the interval is greater than previous end, then new interval is equal to new interval dot start is equal to start. No. Prev end new interval dot end is equal to start. And then res append new interval. And for the ending, prev end is equal to max of prev end and end. This always makes sure that we're discarding the smaller of the two ends. We always want to make sure that the end extends as long as possible when we're iterating through. Turn other way. Nice. Okay, so that was done pretty quickly. I think my memory complexity could have been better. I don't think iterating and creating this was necessary, but it helped with readability and iterating through the code. If I'd given more time, I would probably figure out a way to do this, but I think the way we did it was fine. If we're trying to just iterate through the schedule normally, we would need to check each list and then check what is the smallest in each list. Or we would need to use, we would need to keep a heap and constantly pop off from the heap the smallest element so far in all the intervals, which is time complexity wise, it would bring the space down from the entirety of the schedule to just the number of lists in the schedule, which is a bit better. but again, this was very readable and easy to work through. Time complexity, we have this sorting function, which takes all of the values in each list, and we'll call that n, and sorts them, so it'll be n log n. Here we're just doing a constant operation and doing comparison. This is O of n, where n is also the size of all the elements in the list, so we're dominated by n log n. But yeah, I hope you enjoyed. I'm pleasantly surprised that I got this quickly, even though my space complexity wasn't the best.